Programming with SQL. Mathematical functions. When we think about solving analytical problems, we often think of programming languages. Structured query language was made primarily for retrieving data from databases and operating with tables. However, it can be used for some basic mathematical analysis. Actually, if you think of making calculations on tables, we recommend thinking of SQL first. SQL comes with a handful of built-in mathematical functions. We will cover those that you will most likely use the most and show how to run it on the SQL server. The first two functions we will start with are ABS and sign. The first function returns the absolute value or module for the number, and the second checks for the sign. If the number is positive, the sign function returns 1. If negative, then -1. The rand function returns a random float number between 0 and 1, excluding 0 and 1. This is the only non-deterministic mathematical function in SQL. If you will provide the rand function with a seed as an arbitrary integer value, then the outcome will be reputedly the same throughout your script, no matter how many times you use the rand if the seed is the same. If you do not provide the seed, then the rand function will generate different random float numbers on each function call. The exponent, square root, square, and power functions are intuitive in use. The square root and square functions are shortcuts for the power function with 0.1 and 2 power argument respectively. The log function is a natural logarithm, or the logarithm with the exponent in the base. The log10 function is a logarithm with 10 in the base. The sinus, cosines, and tangent are standard trigonometric functions. These functions receive the angle in radians as argument and return its sinus, cosines, and tangent values respectively as float values. In some cases, you may combine the functions and use round function with the other mathematical functions to receive the values with the accuracy you need. Finally, the pi function returns the value of pi. This function does not have any arguments. Now we will show you how you can run the considered mathematical functions on the SQL server. For that, you can use the select statement. As we move further, you will see that the mathematical functions can be used in a number of ways. Variables. Variable is a value that can change. The concept of variable is key in computer programming. The SQL server has system variables that we cannot control, but also an option for creating new variables. The variable should be declared and set. For that, SQL has two commands, namely declare and set. In SQL, the variables have to have an @ sign prefix. The system variables, the variables that cannot be changed, have two @ signs. When we declare the variable, we specify the data type. Variables can be numeric or character. This is what is called scalar variable, and variables can be tables. We will show the example later on. The scalar variables can be used for any algebraic operation. Also, SQL has so-called compound operators. Compound operator modifies the original value and sets the original value to the result. The compound operator can add a certain amount to the value, subtract, multiply, or divide by a certain amount. We show here the most used compound operators. In this example, we declare an integer variable and set its value to 10. We can view the content of the variable with the select statement. Now, with the compound operator, we add 5 to the myInteger variable. The new variable value is 15. If we will apply the compound operator again and subtract 5 from the variable, we will get the initial value of 10. The compound operators are very handy when you need to increase or decrease the numeric variable value. As we said before, the variables can be tables. We will declare a new variable as a table and simultaneously define its column names and data types. Here, we will populate the table variable with the imaginary kid age data. Then we will declare a scalar variable where we will store Emil's age. We will set the variable using a select statement with the filter. Setting variable values with select statements is a great advantage of SQL. This process will work with any other tables or views. The only restriction here is that if you are working with scalar variables, then the result of the select statement should be a single value. We can view the Emil age now, selecting from the Emil age variable. And of course, we can select data from the table variable in the same way we work with other tables and views. Conditional logic. There are situations when you can have several possible outcomes depending on the initial conditions. SQL has two forms for working with conditional statements, the if-else operator and the case operator. At first, we will explain how to work with if-else operator in SQL. Else operator is optional in the if-else pair. However, we recommend using it. The process for working with the if-else operator in SQL is similar to other programming languages. The if operator checks the condition statement. If the condition statement is true, the operator commands the SQL server to execute the SQL query followed by the condition. If the condition is false, the SQL server is instructed to execute the SQL query after the else keyword. If statements can only execute a single SQL query statement. You can overcome this limitation by using the begin-end block. The begin-end keywords signal the SQL server to treat the SQL statements inside the block as a single piece of code, a single block. We will illustrate the if-else statement with the begin-end block with the following example. At first, we declare a local variable in a bit data type. We will use this variable in our condition statement. The bit variable can only be 1 or 0. We set it to 1. Now we start constructing our if operator. With the following query block, we instruct one SQL server to execute two consecutive select queries if our variable is equal to 1. First query shows a message. Second query selects a filtered subset of data. Here it is a list of companies with a stock price greater than 100. With the else command, we instruct the SQL server to execute another block of SQL statements, namely show a message and list all companies from the table. The execution of the script results in a message and the list of companies according to the if condition. Let's change the value of our bit variable and set it to 0 and execute the whole script again. Now the SQL server walked through the else branch of the if-else operator. The result window shows a new message and a new set of data according to the queries in the else block. The other conditional logic operator is the case operator. SQL Server distinguishes two types of the case operator, the simple case and the searched case. The simple case operator evaluates an expression in its argument. The expression is an arbitrary user code that returns a single value. If this value is equal to the value 1 in the first when clause, then the SQL server executes the SQL query following then keyword and so on. If two when statements have the same value, then SQL Server executes the query after the first valid when statement. If none of the values are found in the when statements, then the SQL Server executes the query after the else keyword. The else branch in case operators is optional. Minimum number of when statements is 1. Maximum is 10. In the searched case, the SQL Server values the conditions in the when statements. It does it one by one, the same as in the simple case. When the SQL Server finds a condition that is true, then it executes the SQL query after the then keyword. If none of the conditions are valid, then the query after the else keyword is executed. An important note is that you cannot have begin-end blocks in the case operators, both simple and searched. The great thing about the searched case is that it allows to replace values in the results of a select query statement. We will illustrate this with an example. At first, we will construct and execute a query with the simple case. This case operator will calculate the length of a stock ticked for each record in the select query output. This length operator returns an integer value. If this integer value is equal to 1, then the ticker lengths column will receive a new entry 1 letter. If the ticker length is 2, then the ticker lengths column will receive an entry 2 letters, and so on. If the ticker length is more than 4 letters, then the new entry value is a string more than 4 letters. This was a simple case. Now let's construct a query with the searched case. The new select statement has a variable tier, which can be 1, 2, or 3. The value of tier for each company depends on its stock price value. If the company's stock price is less than 30, then the tier value is 1. If the stock price is between 30 and 100, then the tier value is 2. Else, the tier is 3. Here we assume that the companies of tier 3 have stock prices greater than 100. Finally, we order the output results by the tier value. This is another way of splitting your data sets into buckets or tiers for your future data science work. Here you can explicitly control the boundaries of the subsets of data. Lastly, we will demonstrate how you can set variable values with the case operator. For that, we declare two variables, an integer and a string. The integer variable will be used in the condition expression of the case operator. Now we will set the string variable. For that, we will use the case operator. If the integer variable is equal to 1, then the string variable will be tier 1. If the integer variable is 2, then the string is tier 2. The same for the integer 3. If the integer variable is other than 1, 2, or 3, then the string variable is set to not defined. Now let's execute this piece of code. The select statement generates a result table with the string variable equal to tier 1. If we change the integer variable to other values, we will see that the string variable will change its values according to the branches of the case operator. Loops. Loops or cycles are repeating parts of code which are executed while a stopping condition is not fulfilled. In SQL, the loops can be created with the while command. The SQL statement after the while command is keep executed over and over again while the condition statement is true. To include more than one SQL statement in the loop, we can use the begin-end keywords to form a block of code. We will show how to construct the while loops with an example. At first, we declare an integer value that we will use as a loop counter and set it to 1. Next, we create a simple loop that prints the counter value to the message window and increments it by 1. Note that we are using a compound operator for incrementing the counter variable by 1. And since we have more than one SQL operator in the loop, we use the begin-end keywords to form the code block. Now we will demonstrate how we can do calculations with the loops. For that, we declare a decimal variable that we will use as an increment. We will change it from 0 to the value of pi. At each loop, we will evaluate a sinus function and break the loop as it will equal to the square root of the 2 divided by 2. When it happens, we convert the variable from radians to degrees and print it to the message window. Not surprisingly, the variable is equal to 45 degrees. Note that we used the round function to reduce possible decimals in the outcome value. Since we used the finite value 0.01 for the loop iterator variable, the inaccuracy in this method for computing values is inevitable. Custom functions. Sometimes you will need an SQL function that meets your specific needs. Custom function is a routine that accepts parameters, performs an action, and returns the results as a value. If you routinely use a certain piece of code in your work, it is a good idea to wrap it in a custom function. SQL Server allows you to create 3 types of functions: custom functions, stored procedures, and triggers. We will start with a create function command. With this command, we can create 2 types of functions, a scalar function and a table function. The scalar function returns a single value. Starting from SQL Server 2016, we can create a new function or alter an existing function with the same name with a single command. Alter keyword is optional. The custom function can accept 1 or more variable as a parameter. In the latter case, use a comma to separate the variables. The function will return a value of a data type specified after the returns keyword. To call the function, we can use select operator or just use the function name as it is a regular math function. We would like to note here that the custom functions can be nested. One function can call another, and the nested structure can be as deep as 32 levels. In this example, we will create a scalar custom function that calculates the length of a string. We will use begin-end keywords to wrap declare and set operators in a single code block. After the function is created, we will use select operator to call it. The custom function is a database object, so we use a DBO prefix before the function name. Upon execution, the function returned the length of the string we specified as an input. Table custom function is similar to the scalar custom function. The only major difference is that it returns a table as an output. The SQL expression in the body of the table function has to be inside round brackets. We can retrieve data from the table custom function in the same way we work with tables using select operator. The simplest way to think of the table function is as a view with the parameter. In this example, we will create a table custom function that returns a list of companies from our table with the stock price above an arbitrary threshold. We will write a simple select statement with a filter in the body of the function. The filter has a threshold variable as a parameter. To call the function, we use a select statement where we retrieve all data from a table generated with the function under a certain value of the threshold. As we can see from the resulting table, we got the list of companies where the stock prices are above the threshold of 100. The other way to create custom functions in the SQL Server is to create stored procedures. The stored procedures may look like the regular functions that we considered earlier, but they are not. In contrast to the regular custom functions, the stored procedures can modify the database state. In other words, with the stored procedures, you can create, delete, and modify the database objects. However, unlike functions, the stored procedures do not have an input parameter and do not have to return a value. To execute the stored procedure, use the keyword execute or a short word exec. The stored procedure that we will show in this example will create a backup for the table company by sector. It will copy from the source table entries where the stock price is greater than the threshold. The threshold will be specified by the user upon the procedure execution. At first, the procedure will try to drop an existing backup table. If the table drop command will raise an error, the procedure try-catch block will catch the error and print the working message instead of stopping the execution. By the way, you can use try-catch structures in other SQL codes beyond the stored procedures. After the procedure is created, you can find it in the database among programmability database objects in the list of stored procedures. If the list is empty, then right-click on the list name and select Refresh from the menu. Now, we execute the procedure with the execute command. Since the backup table did not exist before we ran the procedure for the first time, the drop table command could not find it and resulted in an error. The stored procedure caught the error and printed the warning message. After that, the execution went smoothly and the table was copied. We can check that the backup table was created and it is not empty with the select statement. As we see from the result table, all stock prices are greater than 100. This is how the threshold parameter was set upon the stored procedure execution. Please note for the future that when a procedure is executed for the first time, it is compiled to determine an optimal access plan to retrieve the data. Subsequent executions of the procedure may reuse this plan and run faster. The third way for creating custom functions is to create triggers. In fact, a trigger is a special type of stored procedure. Triggers are automatically executed by the SQL server when a specified event occurs. The SQL server distinguishes three types of triggers: data manipulation, triggers that can modify the data, data definition triggers that can create and delete database objects, and login triggers that react on the SQL server login events. When we create a trigger, we have to specify its scope, a certain table, a database, or the whole server. The most commonly used triggers are those that react on table insert, update, or delete actions. Like other functions, triggers can be nested to a maximum of 32 levels. The trigger that we will create here will warn the user that a database table was dropped. This created trigger is idle unless it will detect a drop table event in the database. If so, then it will execute, or fire, as developers say, and print the warning message. We can find the list of triggers in the Database Triggers list in the Object Explorer. Let's see how the trigger works. We will drop a table with the drop table command. Right after the command was executed, we see the warning message in the message window. This is the message that we wrote when we created the trigger. For the future, you may create triggers that will block the drop table events with the rollback command instead of print, or execute a stored procedure for creating a backup copy.